we're going to get started. And so I want to kind of go through this week's homework assignments and answer any questions with you. But before I do that, I'm going to bring back up the Blackboard screen and go down to last week's meeting and just kind of recap with you guys. Like last week, we talked about kind of the layout of the program. We talked about grades, we talked about makeup work, and I'm trying to make sure that everybody knows if they have makeup work to get that turned in. If you have quizzes or tests that it says that you have a 0, go back and to take those. I saw that Gwen, you turned your stuff in
The
for the
AOPA
AOPA, the
quiz.
AOPA communication assignment, and I'm kind of encouraging everybody else, if they haven't done that yet, I'm still taking it, and it'll help boost your grade. The whole purpose of that time zone assignment was really to get you to look at how to take a time from local time. Let's say you were taking off in California, and if you look at that assignment, the whole purpose was to take the time from the local time. So let's say you were departing in California at 10 o'clock a.m. and you flew all the way to New York City, and the flight lasted 3 hours, just hypothetically for this flight. The question, the whole purpose of the assignment was really to say, what time would you be arriving in New York City? And to understand that, you know, there's a big difference between local time and in one location and in another. So if you're taking off in Pacific time zone and you're arriving in Eastern time zone, it's not just a 3-hour difference. You also have the differences in the time zone, and that complicates things. So you have questions on the FAA exam that follow right along with this kind of problem that say, if it was 10 o'clock a.m. and you take off for a 3-hour flight and land in the Eastern time zone, what time would you arrive? And the video worked out that process very well. It said, first you want to convert the local time into the Zulu time zone. And so you would take the conversion table that would be provided with the question, you change it into Zulu time by adding a certain number of hours. So if it's Pacific time, you're going to add something like 8 hours to that local time zone. So 10 o'clock, if you work in a 24-hour clock, becomes now 1800 Zulu. You fly for 3 hours, which means that you're going to arrive at 2100 Zulu. And then you would, if you need to, convert back into the new local time zone. So in this case, going into the Eastern time zone, maybe you're only going, it's a 5-hour conversion. So you subtract back that 5 hours, and that puts you at 1600 local for the Eastern time zone, which would be 4 p.m. Right? So you took off at 10 a.m., you only flew for 3 hours, and you're actually landing at 4 p.m. because of the time zone differences. And when you do the second half of that assignment, it's even more complicated because you're crossing multiple time zones, not just 2 or 3, but something like 6.
It was 7, but yeah.
7? Yeah, it's a large number, and that really can complicate it. And the FAA has a number of questions on these time zones that they want you to work those out. So, if you had a little trouble with the concept, I'd recommend to go back and watch that video again, because the video gives you some examples of what the FAA question would look like, saying you took off at this time and you landed at this time, but crossing the time zones, what would be your arrival? So the questions on Tuesday's assignment, it was really focused on the different types of materials you would use to actually plan a trip. And so you had your VFR sectional chart, the map. If you had a plotter or a protractor and a ruler, the question was, how do you use these tools to plan a flight? And I'm going to kind of go through the answers on this before we start looking at that process today. But it said that you're going to use the chart and the plotter to draw and measure your course that you're going to fly from one location to another. And it's very important that we get the terms and the definitions correct here. There's starting out with a course. If you draw a line on a chart from one point to another and you measure that direction, because the chart is oriented towards true north, your course is going to be true. And it's called a course. When we convert the course for the wind, we get what we call a heading. And the video, it asked those questions. It said, what's the definitions? I think that was Wednesday's assignment. And it said, what's a course and what's a heading? And the difference between a course and a heading is the wind correction. Mm-hmm. And so the next, to actually get that step, you have to convert your wind correction angle using some type of flight computer. And it can be the old style, like E6B, the big flight computer that I had in the classroom, this kind of thing. And you would use the back side of it to actually do the calculation. Or did you guys, the whole purpose of yesterday's assignment was to play around with the CX3. What do you all think of that?
It was kind of confusing, but I did get it at the end.
This flight computer, you can see it. You can use this actually on the FAA exam, which is very handy because it does a lot of calculations. And that was the purpose of the video yesterday. I know it was a long one. It was like 30 minutes long, and the instructor was just going through and showing problem after problem after problem that they actually were FAA examples from the test. So, but the whole purpose of that was to introduce you to this flight computer and show you how it works. And I encourage you to go kind of mess around with it. But like the first menu here, the unit conversions, you can go to any of these and you can say say temperature, and I can say that the temperature is 15 degrees. And I want to convert that. I can convert that 15 degrees Fahrenheit. I can put it into Celsius and say, oh, it's -9 Celsius. Or if I accidentally left it in Fahrenheit, I can change the unit here with the set unit. So you have these two buttons to either convert it from one to the other or to change the unit. And when you type something in here, it actually will remember that when you go to do other calculations. So say you're trying to do an altitude calculation, we can change our indicated altitude, correct for non-standard pressure, get our pressure altitude, correct for non-standard temperature, and get our density altitude. So when I come down here, a lot of times it'll carry forward anything that's typed in there. So if I told it, we had 1,000 foot indicated and the pressure was 29 let's just say 50, it'll give me my pressure altitude, and then it should, most of the time it'll carry forward that that value for you, which is handy. But it has lots of calculations, and what you're going to need to do is to go through, you'll remember some of these from, say, like the weather unit, where we talked about how to calculate the base of the clouds in AGL by telling it what the temperature is and the dew point spread, and it'll calculate the height of the clouds above the ground. And so you have all these. The ones I really want to focus on today are the section on wind correction, and then the time, fuel, and distance questions. So going back to what we just said, a course is your path over the ground. And so when you measure on your chart, you're going to get a course, and you use your plotter to do that. And so one of the issues I had with this particular, one of the issues I had is that you all working at home probably don't have one of these. And so that's a big part of these navigation questions, is to measure the direction. And so what I've had to do is to give you the true course in the questions, and just say, understand that every time that you're given a true course, what you would be doing is measuring the direction on the chart as your starting point, as the direction you fly from one place to another, and then correcting that first for winds to turn your true course into a true heading. Then after you do that, the next step is to convert it into a magnetic heading, and then finally a compass heading, correcting for variation and deviation. And these definitions are very important, which was the purpose of that assignment on the definitions. You know, we just said that you can use those plotters to measure your course. The question 2 said, is there a relationship between latitude and longitude in inches? And we've talked about this before the break, but the video also talked about how they break up the lines of latitude and longitude, each degree, into 60 minutes. And so 1 degree is 60 minutes. And what's interesting is 1 minute of latitude is equal to a nautical mile. So between 1 degree of latitude, there's 60 nautical miles. So you could actually use those, if you didn't have a plotter, you could use those minutes of latitude from your chart here, these minutes of latitude, and you could actually use those, if you say measured the distance from one place to another, use these minutes of latitude to kind of measure distance.
Mm-hmm.
So if you measure, if you had a ruler and you measured the distance from one location to another location, and then you put that on the minutes of latitude, it would also tell you that distance in nautical miles. So there is a relationship there, but it's not the same. You can see 1 minute of latitude here is very different than 1 minute of longitude.
Longitude, yeah.
So don't get those confused.
Yeah.
Now, not all plotters are equal. Question 3 on Tuesday's assignment said, what does the rotating part of the plotter have in common with a protractor? My plotter and the plotter that they used in the video is fixed. So your this kind of protractor scale that would show you the angle is set, and you have to just read it. There are some that we use in the classroom, and I really like them, that this section actually you can turn it and you can read the angle, and it's a little bit easier to read than these fixed plotters. But again, I told you that's kind of one of the limitations of trying to do this online. If you don't have all the tools, you won't be able to measure courses. So we'll just have to understand, anytime you see true course, it's something that's measured with like a plotter. Going back to this, it says both tools will measure the angles, but one is limited. You know, if you're using a protractor style plotter like I have, you're kind of limited and have to work with that. You're not able to turn it. So question 4, what kinds of scales are available on the plotter and which one should you use? Well, there are different charts that exist too. There are 3 different scales. And so one of the things to know about the plotters too, you have to make sure when you're trying to measure distance with the plotter that you're using the appropriate scale. A sectional chart like we see here, the scale is 1 inch equals 500,000 inches. It's 1 to 500,000. But there are other types of charts out there. We have terminal area charts, which are a little bit more zoomed in, and they have a lot more detail because you're going to be operating in, say, a busy class Bravo airspace, and they're 1 to 250,000. So it's twice as much detail. There are still a few places that use what we call world aeronautical charts, and you can see here those are much less detailed than a sectional. They are 1 to 1,000,000, so it's got half as much detail as a sectional chart, because 1 inch equals 1,000,000 inches on this chart, and so there's not as much to see on those. And so if you're trying to measure distance with a plotter, you need to make sure you're using the appropriate scale for the chart that you're doing, because if you used a sectional scale to measure distance on, say, a terminal area chart, your distances would be twice as much as what they're actually supposed to be. And then also paying attention to that scale if you're measuring in nautical miles or statute miles, because there's a difference there, and that's a common error that you know, oftentimes these plotters will have on one side statute miles and on the other side nautical miles. And if you're doing miles per hour, you want to be using statute miles. And if you're doing knots, you want to be using the nautical mile scale. So make sure that you pay attention to that. So
Yeah.
that's why it's important to select the proper scale, or your planning would be with the incorrect distances. So we talked about time zones. We just talked about measuring course. Continuing with that discussion about the language of navigation, like I said, the definitions are really important. So what did we say it's called when you measure the direction on the sectional chart? Do you remember?
Course.
Like what? Wait, what do you mean? Like,
when you measure the direction on a sectional chart, say you were looking at this and you wanted to measure on a sectional from one airport to another, and you laid your plotter on this chart and say from this airport over to this airport, and you measure that direction using your plotter, what would we call that direction?
true course, or
It'd be a true, yeah, it's a true course.
that's what I was looking for.
So the reason it's true is because this chart is oriented, we said, towards true north. And it's a course because you haven't corrected for the wind yet. When you just take your raw direction reading with the plotter, that's called a true course. And that's your beginning for navigation. That's your first step. So you take that plotter, you lay it out on the chart, you measure the direction, you get your true course, and then you can also measure the distance using the scale.
Yeah.
So now we have to correct for wind to turn that true course into a true heading. And so we move from true course to true heading using the wind, and we'll calculate a wind correction angle. And that was yesterday. When you want to do that, kind of moving into this, that's where you put the numbers in here. So we're looking at true course. Let's just say for that example, I'm going to kind of eyeball it, but from here to here, let's say that looks like maybe 60 degrees. You know, I don't have a plotter on it to actually measure it, but
Okay.
Let's just call that 60 degrees. Well, that's my true course. So I move in.
Yeah.
It needs to know a couple other pieces of information to calculate that true heading. It needs to know, one, how fast am I going to be going? So if we tell it that we're going to be going 100 knots, right, then that's the next piece. Then it needs to know the wind speed and direction. So say the wind is coming out of the south, 180 degrees, and it's blowing at 20 knots. With those four pieces of information, our true course, our true airspeed, the wind speed and direction, it can calculate a true heading, and also can calculate a ground speed, tell you how fast you're going to be flying that path over the ground. So that's one of the things that the flight computer can do, whether you're using a CX3 or an E6B. You can now calculate your true heading and your ground speed, and it says down at the bottom your wind correction angle. So these directions are important. So let's just answer these real fast. It says, number one, the compass direction that points to geographic North Pole, which is the physical location on the Earth where the lines of longitude intersect. Okay, yeah, the geographic North Pole is the true north. Is the path between 2 points expressed in degrees measured relative to geographic north, and this is measured directly off a VFR sectional chart. So it's your true course.
Oh, it's
your
still
path over the ground. This is also known. Your true course is a thing known as your path over the ground.
Yeah.
Like your flight path.
I mean, it says geographical. I mean, I should have thought about that. Like,
yeah, geographic, so it would be true. And we're talking about the angle measure between 2 points on the ground, so that's your course. And this is the same thing as like your ground track, your path over the ground. Compass direction that points to magnetic North Pole, which is the location determined by the Earth's magnetic field and approximately 300 miles away from the geographic North Pole. That's the magnetic north. It's the direction the nose of the aircraft points while it's flying the true course. When there is no crosswind, it's the same as your true course. So we said a second ago, when you convert your true course for the winds, Now you get what we call a true heading, and I just worked out an
True.
example. A true
Okay.
heading. Now, if you convert that path for the difference between true north, so we said you have the true north, and then you have the magnetic north. If you convert the distance, the direction between those, that distance or that direction is called variation. So if you correct your true heading for variation, you're now going to get what we call a magnetic course.
Okay.
Or I guess if you've already corrected for wind, it would be a magnetic heading. So I'll either answer there. Here, I guess, if you called it a magnetic course, which was the example you had up here at the top, magnetic course, you haven't corrected for wind. Is not corrected for wind, a heading is here. So it said the difference between 2 points, magnetic course. The path of the aircraft across the ground, we said that was your ground track. Your track.
True course.
Path over the ground. It's the same thing as a true course, yeah.
Okay.
We hope that our ground track is the same as our true course. Error in the compass caused by different, it says like the installation of the compass.
I said deviation.
Yeah, it's known as
compass deviation. Okay.
The direction of the nose of the aircraft points while it's flying in relation to magnetic north is the magnetic heading.
Magnetic heading.
So as you fly that ground track, the actual direction your airplane is facing is known as your magnetic heading.
Okay.
Which is the same thing as correcting for both wind and variation. The direction the nose points as indicated on the compass after being corrected for deviation, those magnetic errors inside the aircraft, is your compass heading. And that's what we want to calculate. This is the final thing that we're trying to calculate when we do these navigation direction questions. And again, when you go back to this example on the CX2, I said correct the wind to get your true heading. Then the next step, if you want to go to compass heading, is you come in here and you correct in your true heading for the variation, which is listed on the chart by the isogonic line. So you find those purple dashed lines, the magenta dashed lines, like this example, 16 degrees east variation. What do you do with that?
You either add or subtract depending
if it's
16
east. Degrees east.
So
east
subtract.
Is east, we'd subtract it. So on our CX2, we'd say, or our CX3 here, we'd say that would be minus 16.
Okay.
And then that gives us our magnetic heading. Now we've corrected for variation, and we correct for deviation from the compass correction card, which you'd have to look inside the airplane and find out how much it is.
Yeah.
And we give you the deviation. So let's say there was a couple degrees of deviation there. When you do that, it'll finally come to your last answer, which is your compass heading, which is the direction you actually have to fly to end up getting the ground track that you want. So going back to this assignment here to finish these off, not only would we said your CX3 give you the magnetic heading, or I mean the true heading, but it'll also give you the ground speed, the aircraft speed across the ground. And so when you go to do time, speed, and distance questions, this is the one that you would plug into the CX3. Let's go back to the menu here. And you want to know ground speed. You come in here and say, okay, well, if we measured the distance on this flight and we said from that airport to the other airport, and we measured that distance with the plotter using the correct scale and said it was 100 miles. Well, then we tell it, okay, we're going to be going 100 miles. And if it knows the distance and it knows the speed, it can give you the time. How long that is. And if you're like, well, how long is 0.92 hours? Again, you can convert that into hours, minutes, and seconds as well. So that's 55 minutes.
Yes.
So that's the benefit of using the flight computers. You can convert that into lots of different units and see what that time is.
Yeah.
So going back here, the last couple questions, the unit of measure for the rate of fuel used, gallons per hour.
Yeah.
And the CX3 also has a function to do that as well. So now that we know how long the time would be to cover that distance, we can go back into our CX3 and look at the fuel calculation and say, okay, if the flight is going to be, like we said, 55 minutes, and we burn, let's say, 10 gallons of fuel per hour, we can see over that whole flight, we're going to need a total of 9.2 gallons to get from our first airport to our destination.
Yeah.
And so it's kind of really helpful. It's basically saying the amount of fuel is equal to the rate that you burn the fuel times the time that you're going to be flying that distance. The angle between the aircraft's nose and the true course, which compensates for drift caused by the wind, we call that the wind correction angle. And the difference between true north and magnetic north is known as variation. So these definitions, again, they're important. You want to go back and you want to take a look at that if you didn't get it right. So last question, this is probably where most people ran into trouble, was the solving for flight planning. To work these pretty fast, we just kind of worked an example problem here a second ago. But it's starting off, again, with true course. And to recap, how do you measure that? Where do you get that information, that 280 degrees? Where would that have come from?
The section.
Yeah, using the plotter on the sectional chart, the angle from the departure airport to the destination would be 280 degrees. So we're headed pretty much towards the west.
Yeah.
It says we have 5 degrees variation. And it looks like for 270 degrees, you'd steer 268 degrees for deviation. So it wants to know the compass heading. I've got a little problem with this question. What do we not have here to be able to know compass heading? Well, start off with the key word here. It's a course, and they want to solve for a heading. What do you need to do to convert a course into a heading? The difference between a course and a heading is wind correction. So to actually to go from our true course and to come back into our CX3 here and to say we want to go from a course to a heading, we have to know what the wind is. And in this situation, we don't have the wind. And so I think this question is missing that piece of information. Going back into it, let me close this one. Oh, I closed out my window that I needed there, didn't I? Give me a second. I got to open it back up.
Yeah.
So we're missing the wind, unfortunately. So let's just assume that for this question that the wind is 0, and so there would be no difference between your true course and your true heading if the wind was 0. They'd be identical because the difference between a course and a heading is wind correction. And so without the wind, we're just going to have to skip it. So like this question kind of doesn't work. If you notice question number 2, they do tell you the wind correction angle.
Yeah.
But for question number 1, they didn't give you the wind correction angle, and they needed to. Or at least give you the wind so you could use your computer to calculate the correction. So if we finish up question number 1, 280 degrees, saying that our true course and our true heading would be identical, then what we're going to do is convert our true heading into a magnetic heading by correcting for the variation, and then correct our magnetic heading to a compass heading for deviation. So 5 degrees east variation, east is least, we'd subtract 5 degrees, which means now we have a magnetic heading of 275. And here it says on your compass correction card, if you wanted to go 270, you steered 268. So we're going to take that 275 and subtract 2, and we're going to get 273.
Yeah.
Is that what you got?
Yeah.
Okay. So that one is a little confusing, but the second one's a little more straightforward.
Mhm.
And it says our true course is 195 that we measure with our plotter. And we have 5 degrees of left wind correction angle. So I guess that they already did the correction in the flight computer for whatever the wind speed and direction is on this one. And so that means now we have a true heading of 190 with 2 degrees of west variation. West is best. We're going to add that, which goes now to 192. And so kind of splitting the difference between 180 degrees and 210 degrees, it looks like we either don't really do any correction for deviation or we subtract 1 degree, which is very small. So when you make that correction, you're going to end up with something like 191 or 192 degrees.
Yeah.
Either one. I'll take it.
Okay.
And so now you've corrected for wind, variation, deviation. Now, as you did that calculation in the CX2, you'd also get ground speed to calculate the time, fuel, and distance. It's kind of a multi-step process, but looking at this, it says, question 3, the true airspeed, if it was 125 knots and you had a 13 knot headwind, what would be your ground speed?
112.
Yep, it's going to slow you down.
Yeah.
If you had 115 knots with an 8 knot tailwind, that would do what? It'd speed you up.
Yeah.
Justin, do you have a question there?
No, it wasn't a question. I saw a video about there was like a 45 mile per hour headwind or knots, whatever, and the guy was like flying 45 knots and he was just hovering.
Yeah, you can if you take those small airplanes out there on a really windy day and the ground speed is strong, you can pretty much do that. You hover there, or if it gets really strong, you can actually
fly backwards. Yeah.
Over the ground. But the airplane is moving through the air. It's just flying backwards with the wind.
Yeah. Who says helicopters are the only thing that can fly? I wonder if anyone's landed while doing that, right on the dot.
That'd be cool. Let's run through these last ones pretty quick. Distance, it says 114 nautical miles and your airspeed is 110, and it wants to know the flight time. That's a great question for the flight computer. That's a time, speed, distance question. So we come up here and we look at ground speed in the menu, and it said that the distance was 114, and you're going to be going 110 knots. So we say 114 and your ground speed is 110. And that, because they're so close together, it's going to be pretty much an hour and 2 minutes. Okay. The next question, same thing. Distance equals rate times time. So distance equals the speed times the amount of time that you're going to be flying it. So that's what your CX3 is doing here. If you said that the distance was, what did we say it was? 100. And the ground speed in the question was, oh, we don't have the ground speed this time. Yeah, we had the time.
Yeah.
Oops. We have the time, which it said was 1.5. Let me clear that. 1.5 hours. So I'm going to change the unit here. Hours. 1.5 hours. We get 66.67 knots. That doesn't seem right.
No.
Distance. I had
the speed. It was supposed to be the speed.
The speed was supposed to be 100, not the distance.
Yeah.
So this is supposed to be 100,
and
this is supposed to be 1.5, which gives us 150 nautical miles.
Yeah.
So this question is 150. nautical miles. Question 3, the time, speed, and distance question here. If we're going to be going, you just keep typing these in. If you're going to be going for 3 hours, and it says that you're covering 336 nautical miles, you get a ground speed of 112 knots. And then the last ones, it says fuel burns. And so that's basically the same. You guys want me to work those?
Yeah.
To go ahead and work them? Okay.
Yes.
Fuel. We come in here and the question said we're going to be flying for 1.5 hours, burning 8 gallons per hour.
Yeah.
So if the duration of the flight, put this in hours, is 1.5 hours, and we're going to be burning at 8 gallons per hour, that says that we're going to burn 12 gallons of fuel,
12.
which makes sense. We're going to be burning 8 plus an extra 4 makes 12 since it's 1.5. So that makes 12 gallons of fuel used.
Mm-hmm.
The second one, it says if you have 48 gallons of fuel on board and you're burning 8 gallons per hour, how much time would you be in the air before you burned all your fuel? Hopefully you never find yourself in this position.
Yeah. I got 6 hours.
Yeah, that sounds like, so we say it's 48 gallons of fuel on board, and that we're going to be burning through that fuel at 8 gallons per hour, and it says, yeah, 6 hours. So if you divide the total fuel by the rate, that'll give you the time. If distance, if the amount equals the rate times the time, then the time is equal to the amount divided by the rate. So we get 6 hours.
Yeah.
And your last question is kind of the tricky one. You can see the conditions here. We're burning 8 gallons an hour, flying along at 110 knots to do a 240-mile flight. The 10-knot tailwind, it wants to know what's the flight time and the amount of fuel used. So you're going to kind of have to do 2 calculations here. First, if distance equals rate times time, well, we know, let's go back to our flight computer. And we'll go to the, I missed the menu here. Ground speed calculation. We say that the distance was 240 nautical miles. And we're going to be flying at a ground speed. Well, you kind of have to do a little bit of calculation on here. Since your speed is 110, but you have a 10-knot tailwind, what's your ground speed going to be?
120.
120?
Yes.
Which means that you're going to cover that 240-knot distance in 2 hours. So that's first, the amount of flight time is 2 hours. And the amount of fuel burned over that 2-hour period, if we go back, it said we're burning 8 gallons an hour. You could maybe even do this in your head. But if we go back into our fuel and say, all right, we're going to be flying for 2 hours, burning 8 gallons an hour. That means we're going to burn 16 gallons of fuel.
Yeah.
And that's the answer. To the final question. So it's kind of a multi-step process, and that's how a lot of these turn out to be. When you try and work these questions, they often turn into multi-step problems where you're going through and you're having to calculate your time, your speed, your distance, taking the fuel burn to find out the total amount. And so it's a lot of steps, and that's where students can often get overwhelmed in this, is they're trying to figure all those things out, going step by step, and those problems can turn into pretty long problems.